Hi class, this is the Dr. Teixeira teaching about Euclid's fifth postulate. A little bit of a history here. Euclid lived in Alexandria, Greece, around about 300 years before Christ. He was not the first Greek mathematician to consolidate materials of geometry into text, but he was so important. He actually put all of them together, so he is really famous for this material that he did, but he was not the first one. The book, The Elements, it consists of 13 books. The first one is the one that we're going to be discussing in this class, but it contains all the concepts of a plane geometry. There are a lot of other things on the other books, but the course will just cover material from the book 1. Which is called here the most fundamental. There are 23 definitions, and there are 5 postulates. Book 1, there are 48 propositions. What is the difference between a postulate and a proposition? A postulate is something that it's believed to be true. It's just that there is no need to prove because it's a postulate. That's it's assumed to be true. And then with only these 5 postulates, we can develop all the results. The results are called as propositions. What's nice is that, well, we just start with the 5 postulates. In fact, we just start with 4 postulates, and then we try to add, and then do proposition 1, proposition 2, proposition 3. And then once you did, for example, 10 propositions, we can use the postulates and the results to get the new propositions. Well, I talk about the first 4 postulates. The 5th postulate is really important. The idea was, well, they create, and then we're gonna see the result in a few minutes, but they create 5 postulates. But they first create 4 postulates, and then they believe that the 5th postulate was just a result of the first 4 postulates. In other words, well, if you assume the first 4 postulates, it was believed that the 5th postulate was just a consequence of the first 4 postulates. And actually gonna see that the way that is written, the 5th postulate, it does look a little different from the first 4. But then Euclid said, you know what, I can't do this. I don't think that the 5th postulate is actually a consequence of the first 4. I'm gonna state the 5th postulate without proving, but then I'm gonna leave this for the future to see if that's the 5th postulate is actually a consequence of the first 4. The 5th postulate, the way that it's written, the 5th postulate is a little different. It's you see that even the length and the ideas is a little different. It's called the parallel postulate because it involves parallel lines. Well, we have the first 4 postulates, and then that's good. That's no question about the first 4 postulates. But the 5th, we have that, well, it may be a consequence or not of the first 4 postulates. And then hundreds of years passed, and people still think that, well, it may be a consequence. So great mathematicians, they decide to, you know what, let's try to prove it differently. Instead of trying to prove that the 5th postulate is a consequence of the first 4 postulate by doing our proofs, let's try to prove by contradiction. So let's assume that the 5th postulate is actually false, and then we're going to try to put them together, the first 4 postulate with a negation of the 5th postulate, and hopefully you're going to see some sort of contradiction. Well, they did this, but they did not find any contradiction. In fact, it was so nice, this contribution, that they actually developed what's called the non-Euclidean geometry. Well, what's the first postulate? First postulate is simple. A straight line can be drawn joining any 2 points. If I have 2 points, it can be connected by a line. That's it. The second one is, well, suppose you have a segment of line, a line that starts at A and ends at B. Well, I can extend it a little bit. In fact, I can extend it indefinitely into a straight line. You can extend it one side, you can extend the other side, and then you make a straight line. So the third postulate says, you know what? You can draw any circle. Doesn't matter which center you choose and what radius you choose. You can draw the circle. Fair enough. And the fourth postulate says, you know what? All right angles are congruent. So if I have two perpendicular lines, they're going to create these right angles. Right now, I'm trying to avoid using the 90 degrees terminology because I've just talked about the right angles. And the fifth one says, if two lines are drawn which intersect a third line in such a way that the sum of the inner angles on one side is less than two right angles, then the two lines must intersect each other on that side if extended far enough. So that's pretty much the picture. You know, two lines, they intersect, the sum here are less than 180 degrees, so if I extend, they will actually eventually meet here, for example. The parallel postulate says that, well, if a line falling on two parallel lines make the alternate angles equal to one another, then the exterior angles will also be equal, then this line will be parallel. And there are several consequences. If two parallel lines are cut by a transversal, then the corresponding angles are equal. The sum of angles on a triangle equals to two right angles. If a line join the midpoint, it's parallel to the other side. There's a lot of consequences, and what's interesting is that these are consequences of the fifth postulate. So if you imagine a geometry where the fifth postulate is actually false, these consequences are not true. The sum of angles is the same for every triangle. There exists a pair of similar triangles but not congruent. So in other words, what's a similar triangle? Triangles that will have the same angles but different size. So it's interesting to see that this does not happen on non-Euclidean geometries. If three angles of a quadrilateral are right, then the fourth one is also a right angle. Two lines which are parallel to the same line are also parallel to each other. So that's a very common thing to believe. Two parallel lines, if it cuts by intersect, if it intersects one of them, it will also intersect the other. In a right angle triangle, the square of the hypotenuse, that's the Pythagorean theorem. Okay, so I'm going to talk about different geometries where this is not true. So what's for next class? We're going to be talking about non-Euclidean geometry. There are two types of non-Euclidean geometry: hyperbolic geometry or spherical geometry. So these are the geometry where the fifth postulate is not valid. So all these are not valid. So that's a really interesting problem. Okay, if you have any questions, please email me. I'll try my best to answer every question, and I hope you have fun with this material. Please don't forget to complete the homework. Thank you.